Finally, just as a last wrap up, we want to go through some of the steps and tips and tricks that we talked about in this presentation that really should help you avoid seeing a lot of the damage caused by galvanic corrosion. So the first one that we've mentioned several times is the use of a nickel-plated aluminum filler wherever possible. It's really going to help from a shielding effectiveness. It's going to help from a corrosion resistant. And a lot of the times it can be a more cost-effective solution because it uses a nickel as opposed to a commodity metal like silver.
Yeah, and silver-plated aluminum, obviously it's been the gold standard of corrosion for years. It's a mil-spec material. It also has excellent ability to ground as well as shield, so it's definitely a good second option.
The next step would be to utilize a seal-to-seal design. So this is kind of one of the two seal methods that we've used. And instead of having a gasket made up against two interfaces, you actually have a gasket on each interface. So the seal-to-seal method provides you the same level of environmental sealing and is used a lot in aerospace applications. But the benefit is that you're actually minimizing the difference between galvanic materials because the seal should ideally have identical galvanic series.
Yeah, and we talked about when you have the ability to put a second seal, a non-conductive outboard, conductive inboard, but we also have co-extruded with one side being non-conductive, the other being conductive, as well as we can mold custom shapes with conductive and non-conductive. So that's always an option, really eliminate the electrolyte altogether.
Additionally, depending on your requirements, you're going to want to look at surface treatments. So different types of platings of aluminum or steel or tin or nickel, as well as additional top coats like a caulk paint that can protect from environment.
Avoid designs that allow moisture to pool, dripping in water ingress. You want to keep the moisture out as much as you can.
One of the main things that we recommend with our conductive elastomer gaskets is actually staying as far away as possible from a dovetail groove. We do not want to see dovetail grooves. And one of the big reasons for that is that the sharper edges of a dovetail groove can actually damage the conductive gasket and cause some of that conductive filler to create FOD. Now that FOD is typically a pure metal or a metal with silicone or fluorosilicone. So it can cause some corrosion depending on where that FOD lands.
You can always get another protective coating and use additional environmental sealants, caulking things up with silicone or putting top coats on.
And lastly, we talked about this earlier, try avoiding magnesium wherever possible. It's a very reactive material. And when it comes in contact with other less reactive material, we see a lot of damage to that magnesium housing.
We had a customer that had designed a magnesium box because they had serious weight concerns. They came in for an EMI gasket. We actually painted the housing with our Coast Shield 2000 series. And when we put it into the salt fog chamber, we didn't realize that the painter had there were pinholes in the paint. And so when the housing came out of the salt fog chamber, it was literally a shell of 2000 series paint. The magnesium completely disintegrated. So just avoid the M word. No magnesium.